All right, take a moment, please, to rate yourself on the 2 objectives for today and write down what's on the screen. Please pause the video while the students finish. Okay? Now, we are talking about solving compound and absolute value inequalities. The 2 lessons that we've done this week have led us up to this lesson. On Monday, we solved absolute value equations, and then on Tuesday, we solved inequalities. So the next progression is to solve compound inequalities. Some of them look like this. This is a representative of an and compound inequality. Even though it doesn't have the word and, we know that it's an and inequality because the variable is in between 2 inequality symbols. Other inequalities, compound inequalities that is, may contain the word and, or they will contain the word or. Or inequalities will always contain the word or. It's only the and inequalities that you need to be on the lookout for. Now, we're going to solve this and inequality first. This is problem number 1A in your notes. And this inequality is going to be solved the exact same way that we did yesterday. The only difference is that we actually have 3 pieces to work with. We're used to working with inequalities that look like this, where we have to add or subtract to only both sides. Now we have to do that to 3 sides. So I'm going to draw these lines in to remind us that there's actually 3 parts that I need to take care of when I'm solving this inequality. First, we're going to add 2 to each of those 3 parts. And I get that 12 is less than or equal to 3y is less than 21. Now we're going to divide by 3 in all 3 parts. So I get 4 is less than or equal to y, which is less than 7. Now that my variable's alone, I can consider this inequality solved. This is the way that I would continue to write this inequality. It started out with 2 inequalities, all contained into 1 long sentence, and that's how my answer should also appear. We've also been tasked with graphing this solution set on a number line. Now, yesterday, we only had 1 number to contend with, and we put that number right in the middle. Today, we have a couple of numbers to contend with. So what I would like you to do is to make sure that you include at least 1 number on either side of these numbers. So my number line is going to go all the way from 3 all the way up to 8. Graphing this inequality is going to work the same way. I'm going to put an open dot on 7 because it's not equal to. And I'm going to put a closed dot on 4 because it is equal to. Remember, we put it directly on the line, and we should be able to tell whether it's open or closed. Now, the next part is where it can get a little tricky. Over here, with the y is less than 7, it's clear to me that I should shade to the left because y is less than 7 is in VIN form, variable inequality number, with the inequality pointing to the left. But on this side, 4 is less than or equal to y. That's not in variable inequality number. So the trick is, when I have an and inequality, we need to check to make sure that my smaller number is on the left and my larger number is on the right. If this is true, then check your inequality symbols. They should both be opening to the right. That means that this is written in the correct way for an and answer, and my shading will happen in between. Please do not just assume that the shading happens in between. What you can do, though, is recognize that this is an and problem because of the one single inequality and two inequality symbols. And once we get to a solution, I've plotted my two endpoints. Pick a number in between, like 5. Would you say that 5 is greater than 4 and also less than 7, making a true statement? Yes, 5 is greater than 4 and less than 7. So that means that shading in between works. If you were to get a solution set where the numbers in between don't make a true statement, shade according to what the solution set says. Let's take a look at an OR problem. This OR problem has broken it up into two separate inequalities for me. So when I solve this, I will solve the two separate inequalities on their own as well. Focusing on the left inequality, we're going to subtract 3 from both sides. And I get x is less than -1. The right inequality, to get x alone, we need to divide by -1 on both sides. So I have x, and because I divided by a negative on both sides, I need to switch the inequality sign, is greater than or equal to +4. Now remember, the problem directly told me that it was an OR problem. That means that I need to include the word OR in my answer. We've also been asked to graph this. So again, on my number line, I need to include one number past each of the two endpoints. So mine will go from -2 all the way up to 5. Now, because they're two inequalities that have said OR, we're going to graph them independently of each other. These tend to be the easier problems to graph. So on -1, I will put an open dot, and it's in the correct form, variable inequality number. So I'm going to shade to the left because the inequality points left. On the right inequality, we're going to put a closed dot on 4 because it is equal to. And the inequality is pointing to the right, so we're going to shade to the right. Generally, OR inequalities will point outwards and inequalities will shade inwards. but not all the time, so be very, very careful. Now let's talk about inequalities that have absolute values. An absolute value inequality is a compound inequality. An absolute value inequality that is a less than symbol with an absolute value sign on the left is less than a number is considered an and inequality. When it have the absolute value is greater than a number, it's considered an or inequality. Now, we have these two sayings to help you remember which one is which. I know that neither one is spelled correctly, and that's done on purpose so that we can include the word and the word or. So when I have absolute value is less than a number, and is what kind of compound inequality it is. If an absolute value inequality is greater than a number, it is an or inequality. Let's take a look at each of the inequalities below and first label whether it's an and because of a less than sign or an or because of the greater sign. Now remember, we have to have the absolute value on the left side. So we're going to rewrite C, absolute value of D, and 2. It's opening away from the 2, so it needs to continue to open away from the 2. So I have the absolute value of D is less than 2, meaning that this is an and problem. Look at D. We're in the same situation. We need to put the absolute value sign on the left. This time it's opening towards the absolute value sign. So I have a greater problem. Absolute value of D is greater than 3. So this is an or inequality. How about E? E has the absolute value of 2x minus 2 is greater than 4. So this is also an or problem. This trick will only work if you have your absolute value alone and on the left-hand side. Now let's go back and actually solve and graph these solution sets. For and inequalities, we need to rewrite them using this structure. So we have the number that it's equal to or that it's less than below it, and then take the opposite of that number, and it's going to be less than the part inside the absolute value sign. So in this case, I'm going to directly copy what I have above. Notice I don't have the absolute value sign anymore. And to get this other piece of the and, we're going to make it a -2 and another less than symbol. This one didn't have any sort of solving, so we're just going to go straight to graphing it. My number line needs to go all the way from -3 all the way up to +3. Both numbers are going to have an open dot on them. Now, because this represents an and problem, pick a number between these dots, like 0. If I put 0 in here, does it make sense for both inequalities? Is -2 less than 0? Yes. And is 0 less than 2? Yes. So I'm going to shade in between. Remember, don't take for granted that all AND problems get shaded in between. Take a look at the next one. This one is a great or problem. For great or problems, they will follow this structure. 1 gets copied exactly like it is, just without the absolute value sign. And here, I change it to a less than sign, and I flip the sign. So for problem D, 1 gets copied exactly as you see it. D is greater than 3, no absolute value signs. Or D is switch the sign, switch the sign. It's going to take a little bit of memorization and, more importantly, a little bit of practice for you guys to remember. You won't be given anything that will help you remember which ones these are, and you do have a quiz on Friday that covers this lesson. I will be here on Thursday to help you out, but you need to try and practice these on your own. For graphing, our number line will go all the way from -4 up to +4. I'm going to use open dots on both -3 and +3. Now this is an OR problem. So D is less than -3. It is in the same form as variable inequality number, so I will shade to the left. D is greater than 3. It is in the correct form, variable inequality number, so I will shade to the right. Again, do not take for granted that all OR problems will be pointed outwards. Please make sure that you check. Let's take a look at E, which is also an OR problem. We will have two separate inequalities. One will look exactly like the problem, just without absolute value signs. So 2x minus 2 is greater than or equal to 4. The other one will be 2x minus 2 is switch the sign, less than -4. Solve both of these inequalities, please. Pause the video while students solve the inequality. You should have gotten x is less than or equal to -1, or x is greater than or equal to 3. Make sure that you include the word or in your answer. Graphing this inequality works the same way as before. My graph will go all the way from -2 to +4. For this inequality, we're going to use a closed dot on -1, and because it is in the same form for variable inequality number, we will shade in the direction of the inequality to the left. The other one will get in a closed dot on number 3, and we will shade to the right. Again, do not take for granted that oars shade outwards. Turn the page and let's take a look at the back. We have one word problem and then interval notation. I'm going to save that for when I get back. So my word problem says to prepare for a job interview, Hinda researches the position's requirements and pay. She discovers the average starting salary for the position is $38,500, but her actual starting salary could differ from the average by as much as $2,450. We need to write an absolute value inequality that describes this situation. Then we're going to solve the inequality to find the range of Hinda's starting salary. So Hinda's salary, the average for it is $38,500. And if I subtract what Hinda actually starts making, that should give me the difference between the two. And we were told that the difference between the two could be as much as $2,450. As much as indicates that this should be the most that it will vary. So my inequality is going to open to the $2,450. Now, the absolute value portion comes into play when you look back at this scenario. If I want a positive value, that would mean the Hinda would be making less than $38,500, the way that it's written. But it said that it could be more than that by as much as $2,450. Remember, an absolute value is always positive. So we put absolute value signs around the difference between Hinda's salary and the average salary. To solve this, we need to decide, is this an or problem or an and problem? My absolute value is by itself, and it's on the left side of the equation. So I look at the inequality. It is a less than inequality, so that means that this is an and problem. To solve this inequality, we write one of them exactly as we see it. Copy it down without the absolute value symbols. Remember, ands are like one giant inequality that has two symbols in it. So the left portion is another less than symbol, and this time it's negative $2,450. To solve this, recall that we broke them into three portions. So we are going to subtract $38,500 from all three parts. And on the left, I get negative $40,950 is less than or equal to negative X is less than or equal to negative $36,050. Now we need to get that X alone by dividing all three sides by a negative number. So I get $40,950. And remember, dividing by a negative flips the sign. And here I'm dividing by a negative, so this sign will also flip. Remember, with and problems, we always want to write the smallest number first, which would be $36,050, and the larger number goes last. Take a look at your inequalities. It's opening away from the 36,000, so it will continue to open away. And here it's opening towards the 40,000, so it will continue to open away as well. So the range of Hendy's salary will be anywhere from $36,050 to $40,950. Remember, with word problems, we always give a statement. So Henda's salary will be anywhere from $36,050 to $40,950. Remember, we will cover interval notation when I get back. Please spend the rest of the time working on practice problems.